morning, students. So welcome to Mr. Chen's master class. And today I would like to talk about sections 5.1 and 6.1 for the pre-calculus honors. Okay, so we'll take a look at that right here. So for the 5.1, 6.1, this one is all about the unit circle and also finding the ratios of the trig functions. And also it's regarding things that we'll be talking about, such as the arc length, linear velocity, angular velocity, and also the revolutions word problem. Okay, so we'll take a look at that. So the first one, it's all about the unit circle. So you guys can refer back to the other video that I have for the unit circle. So it's things that we talk about in trig already, in trigonometry. So it's about the first quadrant, second quadrant, third quadrant, fourth quadrants, all student to calculus. And then you want to find out those corresponding ratio. And all those special angle, they always consider 0 radian. Because in pre-calculus, so the one that we try to use here, it's all radian. So we rarely use that degree, because the calculator doesn't recognize degree for the graphing. So 0, 30 degree, which is what, pi over 6. And then 45 degrees, which is pi over 4. So this one is just the basic reference. And then right up here, which is what, pi over 3, 60 degrees. And then the rest of that would be pi over 2, 2 pi over 3, 3 pi over 4, and then 5 pi over 6. And then down here, then that would be considered 7 pi over 6, 5 pi over 4, and then all the way over here, then that would be considered 4 pi over 3, 3 pi over 2, and then right over here, 5 pi over 3, 7 pi over 4, and then 11 pi over 6. Okay, so those special radian. So again, it's all based on the special right triangle. So for 30 degree, so right up here, so this one will be cosine 30, sine of 30. So then that would be considered root 3 over 2, and then 1/2 for the xy coordinate. Right here, 45 degree, special right triangle, isosceles right triangle, so it's root 2 over 2, root 2 over 2. And then over here, which is considered 1/2, root 3 over 2. And then the rest of those coordinates, they're just considered reflections. So it's pretty easy to recognize. So for number 2, you want to grab the following. So you want to grab the following angle in standard position and state of the quadrants which it lies. Determine 2 positive and 2 negative coterminal angle. With the given angle, state the reference angle. So again, those are pretty much the basic stuff that we did in trig. And also convert each angle from degree to radian or radian to degree, vice versa. Okay, so let's try the one that's like 2a. Okay, so this one, let me just snip this one and put it into the new slide. Oops. Okay, so number 2. Okay, so there's a technical difficulty right here. Okay, let me just close this out. Okay, so once again, so let me snip this one. Okay, so we're doing number 2a and b. Okay, I'm going to a new page. Maybe this one is a little bit low battery, so let me just plug the power cord. Okay, so now what we found here. So one is measuring radian, the other one is measuring degree. So the quadrant in which this one lies, so 11 pi over 12, obviously this one is lying in quadrant 2. So it's very close to the x-axis for the terminal side. So it's like that. And then determine 2 positive and 2 negative coterminal angle with the given angle. So the way to determine the positive coterminal, negative coterminal, so basically we just add 2 pi. And the other way is what? Subtract 2 pi. Okay, so the rest of that is just algebraic step. So 11 pi over 12 plus 24 pi over 12, then that'll be 35 pi over 12 radian. And then 11 pi over 12 minus 24 pi over 12. So this one would be considered negative 13 pi over 12 radian. Okay. So one is for 1, part 2. State the reference angle. So to state the reference angle, so this one, we do know that it's in quadrant 2. So the way to find the reference angle is pi minus theta. So which is pi minus 11 pi over 12. So which is what? Pi over 12. And then convert the angle from degree to radian or radian to degree. Okay, so this one's given as a radian, converted to degree. So multiply by 180 over pi. Okay, so this one cross cancel. So 12 goes into 180. So 112. Subtract, so 60. And then 15 times. 15 times 11. 165 degrees. And then for the other one, it's quite similar. 420. So for negative 420, so that means this time we need to go by clockwise. So we have to go around more than once on the unit circle. So all the way back to 360, and then add another 60. Okay, so it's all the way here in quadrant 4. And then determine 2 positive, 2 negative coterminal angle. Oh, 2 positive, 2 negative. So this one, you just want to keep adding 2 pi for the previous one. So let's just do this one right here. So this one, negative 420. So, well, let's find the positive first. So add 360 twice for the first positive coterminal. And then for the second coterminal, you want to add 360 3 consecutive times then. Okay. And then for the negative coterminal, so for this one, so for the negative coterminal, so that means negative 420. Subtract 360 once, and then subtract 360 twice, because we need to get both of those. 2 negative coterminal, 2 positive coterminal. And then you want to find out what those angles are. Okay, so now let's see what else. State the reference angle, so negative 420, so that one, it's in quadrant 4. So in quadrant 4, it shows that it's negative 60. So that means the reference angle, it's 60 degrees. Again, so going to quadrant 4 like this. So reference angle is always considered positive. So negative 420 plus 360. And then basically this one can take the absolute value for this. Okay, so now let's see what else that we have. Convert the angle from degree to radian. So negative 420. Times pi over 180. Okay, so 0, 0 got canceled. So this one, 4218. So this one, they're both divisible by 6. So negative 7 pi over 3 radian. Okay, so that's for number 2. Okay, so now let's see what else that we have. Back to the template. So now the rest of this, they might be considered brand new stuff. So it's part of 6.1. So it's about the arc length. So arc length, that means we want to find out the distance of the arc from one position to another position. So let's say that right here is position A, here's position B. We want to find out the distance of this arc. Okay? Or the length. So you might be wondering, it's like a circumference. So the formula for that, it's always like what? 2 pi r. And then based on 2 pi r, we multiply by theta. over 360. So theta, you can say that's degree. So this one, it's just like the basic formula to find out the arc length. But instead of using theta as degree, we want to convert that to radian. So in order to convert that to radian, so it's 2 pi r. So theta, it's already in degree. So now to convert that to radian, so you multiply this one by 180 over pi. So pi got canceled. 180 going to 360 twice. 2 and 2 got canceled. So what's left here is just r times theta. And then theta turns out to be radian. So arc length, would you have two formula for that? Either consider 2 pi r times theta over 360, or r times theta. It's theta, it's in degree. In radian. Okay, so two formulas for the arc lengths. So this one right here, so we do have the arc length, which is 29 feet, and then the radius is 12 feet. And find the measure of angle in terms of radian. So using that, the new formula, r times theta. So radius is given already, 12, arc length 29, theta, we don't know what that is. So theta, so that equals 29 divided by 12. And this one, there's no need to round it, just leave it like that. You can convert it to a mixed number, but just keep it this way, radian, right. And the other one is about the area of a sector. So area of a sector, that means you want to find out the area in between the radii and also being bounded with the arc length. The basic formula to find out the area of a sector, it's about pi r squared times theta over 360 if theta is in degree. But in terms of radian, the formula would be considered pi r squared times theta over 360 converted to from degree to radian, so multiplied by 180 over pi. So pi and pi got canceled. 180 goes into 360 twice, so it's 1/2 r squared times theta. So that means theta, it's in radian form. Okay, so we'll look at that one right there. Number 4, a circular sector of radius 3 inches subtended and in angles of 16 pi over 9. So that means the measure of the central angle is 16 over 9 pi. Find the area of a sector and its arc length. Okay? So let me just tick this one and then put it to the new slide. Okay, so this one, two things that we need to find out: area of a sector and the arc length. And for those you might be wondering, do I need to draw the diagram for this? It's up to you. If you want to draw the diagram, that'd be great. But what happens if I don't want to draw the diagram? Well, basically just want to annotate, because that's just like a short word problem. So we do know that's a circular sector with the radius 3 inches. So r is 3 inches. And then we do know that the measure of the central angle, so theta, it's 10 pi over 9. So area of a sector, so what we found here is 1/2 r squared times theta. So it's 1/2 times radius, 3 inches, squared, times theta, 10 pi over 9. Now this one, there's no approximation, there's no rounding, so just leave that everything in terms of pi with a fraction. So 1/2 times 9, 10 pi over 9. So one thing that we noticed, cross cancel. So the answer would be 5 pi. And the unit for this one would be square inches, because area, it's always two-dimensional. So square inches. And then what about for the arc length? Again, using the formula, which is what? S equals r times theta. So radius, once again, 3 inches, theta, 10 pi over 9. So things that we can cross cancel. So 10 pi over 3 inches. Okay, so just like that. Okay, so now let's see what else. So a merry-go-round of radius 26 feet Complete 1.5 revolution in 60 seconds. Okay, so find the angular speed and the linear speed. Okay, so before we get started with this one, we'll talk about the general relationship about those formulas. Revolutions, angular speed, how fast it spins, okay? The linear speed, so how fast it goes for the merry-go-round. Okay, so let's find out. So let me just make this one first. Again, something wrong with my keyboard here. Okay, so as what I mentioned, so for the revolution, linear angular speed, or the linear angular velocity. Okay, so let's talk about this. So again, so anytime that we do have an arc length, so not only we need to find out the distance, but also we need to find out how fast, that the machine it runs, okay? So we need to find out that the linear speed. So let's say that we do have the speed of a car, how fast you drive, things like that. Okay, so how long does that take in order to go to 60 miles per hour, for the car? So that would be about like acceleration, but now we're talking about the linear speed. So how fast that you drive. So that means the formula for that one would be considered arc length divided by the time. Okay, again, arc length divided by the time. So V, what does that stand for? The linear speed, or the linear velocity. Well, you might be wondering, speed, that's just one direction. It's always what? Positive. But it could be linear velocity. And then S, which is the arc length, and then T, which is the time. So the way to calculate it, meter per second, or miles per hour, things like that. Another one is that the angular speed. How fast the wheel spin. Okay? So that would be considered W. So the way to represent that formula, it's considered theta divided by time. So theta, that would be called the angular displacement. So that means, the measure of the angle is that the wheel spins. The measure of the angle. Okay? And then again, T, which is the time. Okay, so this one's called the angular velocity. And for those you might be wondering, what about the relationship of the linear velocity and the angular velocity? Let's find out. Okay, so let's say that T, then that would be considered S over V. And then over here, T equals theta over W. So now what happens if these two times, they're considered equal? So if they're equal, guess what happened? So that means S over V equals theta over W. Again, what's S? It's considered R times theta, because that's the arc length. Theta over W, just keep it that way. Compare and contrast. As you can see that both sides, we do have theta. So basically we can divide it by theta on both sides. So what's left here? So that means R over V equals W. And then cross multiply. So what do you guys notice? So that means, okay, so that means this one right here. So R theta over V, and then theta over W. Okay, so again, theta, so simply cancel, and then cross multiply. So we got V equals R times W. Okay, so forget about that one right there, I was wondering. So this one is just like a short proof, the short algebraic proof, the way to find out the relationship of the linear velocity and the angular velocity. Okay, so now let's go back to this one. Okay, so a merry-go-round of radius 26 feet. Okay, radius 26 feet. Complete 1.5 revolution in 60 seconds. So this one basically tells you that the number of times, you know that merry-go-round going in 60 seconds. So it goes 1.5 revolution. So 1 revolution is considered 2 pi, and now it's 1.5 revolution for every 60 seconds. Okay? So now what does that tell you right there? We'll find out, okay? Okay, so let me just clear that all the notation first. Okay, so once again, radius, 26 feet. And then 1.5 ReV for every 60 seconds. Okay, so keep that in mind. 1 rev is considered 2 pi. Because once you go around once on a unit circle, it's considered 2 pi. So find the angular speed and the linear speed. Okay, so first thing that we can do, so 1.5 ReV for every 60 seconds. So in other words, that means it's 1.5 revolution per minute. Okay, so in order to convert that from ReV to radian, guess what we can do? Multiply by 2 pi. So 2 pi radian for every single revolution. Okay, so the same unit cancel. So now what we got here is 1.5 times 2 pi. Again, leave the answer in terms of pi. So what we found here is 3 pi radian per minute. And guess what this one is? W, angular, the angular speed. Okay, what about the linear speed? Again, using the general formula, the one that we just went over. So V equals R times W. So radius, 26 feet, times W, which is 3 pi radian per minute. And then 26 feet, you can say that. So this one, it's over 1 radian. So radian, convert it, cancel. So 3 pi times 26. So what we found here, it's 78 feet per minute. 78 pi feet per minute. Don't forget about the pi, it's part of the conversion. Okay, so here we go, angular speed and then the linear speed. Okay, so now let's go back, see what else that we got right here. So Roger drives a car whose wheels have a diameter of 26 inches. If the wheels rotate at 600 revolutions per minute, again, another ReV per the unit, the time. And then find the speed at which his car is traveling in miles per hour. Okay, so that means we need to find out the linear speed. Okay, so first of all, let's find out the angular speed first. Okay, so just want to take this one. Okay, right here. So the first thing that you want to do, again, annotation. Doesn't matter what kind of word problem that you're dealing with. So always highlight a keyword, key number. Keep that in mind. The one that's given, it's the diameter. It's not the radius. So divide this number by 2. So we got what? 13 inches for the radius. And if the wheels rotate at 600 revolution per minute, 600 RPM. Okay, so 600 revolution. And now we want to convert that to angular velocity or angular speed. So 600 ReV times 2 pi radian over 1 rev. Again, cross out the same unit. So 600 times 2 pi, then that'll be 1200 pi radian per minute. And then once we find the angular speed, guess what we can do after that? We can find out the linear speed. But keep that in mind this time, the final unit got to be miles per hour. Okay, we're going to deal with that but let's convert this one to the linear speed first. So we do know that v equals r times w. So radius we do have, which is what, 26 inches. So that's just the excuse me. So that one is just the diameter. So the radius is 13. So 13 times w, 1,200 pi radian over 1 minute. Okay. So again, 13. So that one is what? Right now it's inches. Okay, so the radian got canceled eventually. Divided by 1 over 1 radian, because that you want to cancel out the radian. This one just say that's 1. And what we found here, so for the linear velocity, so eventually it turns out to be 13 times 1,200 pi. Okay, so let's find out. So this one is considered 156,000 pi. Actually, it's 15,600 pi. And the unit for this one, which is inches per minute. Okay, so now the thing is that the unit, we need to convert that to miles per hour. Okay, so for step 3. So convert this one to miles per hour. Okay, so basically this one for the inches, we want to convert that to miles first. So from a small unit to a big unit, so that means we have to divide it. So we do know that, so 1 foot is what, 12 inches? And then 1 mile. So that equals 5,280 feet. Okay, so multiply the number. So divided by 12 and then divided by 5,280. And then let's see what else. So once we convert this one to miles, and then we need to convert the time to hours. So from a small unit to a big unit. And then after all this, so we need to multiply the rest of this by 60. Okay, so convert that to time to hour. So we do know that 1 hour, so that equals 16 minutes. So again, the reason why that we do it like this way, so we can cancel the same unit. As you can see, that feet cancels out with the feet. So mile, well, this one is inches, cancels out with inches. And then minute cancels out with minute. And then you see the final unit remain here. It's what? Mile per hour. Okay, so just multiply those numbers straight across and then divide it, and you'll find out what that is. Okay. So now let's see what else. Back to the template. Okay, so the other one. So Kristen rode her bike for 2.8 miles, and the radius of the wheel of her bike is 16 inches. How many times did the wheel turn? Measure from the lowest point on the wheel. So that means we need to find out the number of turns, okay? Or the number of revolution, okay? So the number of revolution. Okay, so one thing that we notice, so we do know the arc length, 2.8 miles. And we do know the radius. Okay, so the radius of the wheel for bike is 16 inches. So radius, 16 inches. So first thing that you want to find out is about the linear Well, let's find out theta. Okay, so there's no need to find out the linear speed. Once you find out theta, guess what we can do? We can convert that to the number of revolution. Okay, so two-step problem. Okay, let's put it right here. Okay, so first thing that you want to find out is that theta. Well, the reason why that we need to know theta, because once we get theta, we can always convert this one to the number of revolution. Because 2 pi radian, so that equals 1 rep. Okay? So, in order to find theta, using the arc length formula, so S equals R times theta. So the arc length, which is what, 2.8 miles. And then radius is 16 inches. So now this one, got to be careful. You probably want to convert that miles to inches first. So 2.8 times 5,280, convert to feet, and then convert that to inches, multiply by 12. Okay, so that's the arc length. And then radius, that's what we need to, well, we already know that is 16 inches times theta. And then from here, solve for theta. So 2.8 times 5,280 times 12 divided by 16. So we can do that on the calculator. So once we solve for theta, guess what? Step 2. To find the number of revolution. So the way to do it, so basically we divide theta by 2 pi. Okay? So this one is a simple test. But the thing is that, got to be careful, the unit conversion. If you find out the unit doesn't match, so that means we need to convert that to the same unit. Okay? So again, any questions, any concern that you have for this lesson? So this one, again, it's 5.1 and 6.1 lesson from the Pre-Cal James Stewart textbook. Okay? So make sure that you guys either rewind or fast forward to the part of the content that you guys having difficulty with. Okay, so thank you for watching the video today. So I'll see you guys next time. Take care.